Okay, today we're looking at problem 10 out of chapter 7. Problem 10 is a manufactured type problem. So we have some different pieces here. We have a plate here. This plate is a 10 by 1 plate. So we have two channels here that are symmetrically aligned. That is a C 10 by 30. So we're going to have to go back to the appendix A and look those pieces of information up. The critical pieces on that are going to be the depth, the area, the moment of inertia, and then this little guy, which is the distance from the back of this to the centroidal axis in that direction. We would also need to start out by solving the centroid of the composite, and I've already done that, so if you're not sure how to do that, make sure you look back at chapter 6, and you should verify my answers. But I determined from this corner it's 5, it's symmetric. That should make sense. Because this plate is sitting on top, it's pushed the centroid up, and that should also make sense. So this turned out to be 6.99 inches. So we're going to need the area of this shape. We're going to need the IXC of this shape, the IYC of this shape, and then we'll need this distance and that. So if we go to the chart, we are looking at a 10 by 30. There's our area and there's our depth. So let's go ahead and we'll put those in. We got area and depth. There's depth is 10 inches. Area was 8.81. Okay. The IY and IX, let's see, we've got, here's our 30. So here's our moment of inertia about the x-axis, 103. And here's the moment for the IY, so 393. Okay, so this is 103, and that would be inches to the fourth. And this is 393? Yeah, 393 inches to the fourth. So the only other thing we need is this distance here, the x bar distance. So we're looking at that, and that's going to be 649. So we're going to put that here, 0.649. Okay, so we'll go ahead and construct our chart. We're going to have a shape and an I. In this case, we're looking at the X first. Area, the D distance, the A, the D squared, and then ultimately IX. So what we're looking at is doing the parallel axis theorem. And D, remember, is going from x-axis to x-axis, okay? So we're going to look at this shape. We'll call this shape 1. So shape 1. The moment of inertia is 1/12 the base times the height cubed. The base, remember, is going this way in this case, so it's going to be 10 times 1 cubed divided by 12. Doesn't give you much resistance to bending. It turns out to be a very low number, 833. Area is going to be 10 times 1. That's 10. So D is the distance from this axis line to this axis line. So basically what you're coming up is you got 10 plus a half. So 10 and a half minus 699 would be the distance between. And so that gives us, if we do that math, I'm coming up with 3.51 inches. So we're going to square that, multiply it by the area, and we should come up then with 123.201. That added to that is going to give us 124.034 inches to the fourth. Okay, so we're going to look at this shape now. We're going to call that shape 2. So shape 2, we're looking at the IXX of that. That's a 103. So that's actually generating most of the stiffness. The plate's really not doing much in this direction. So the area of that, we look the area up. That's 8.81. Again, that's coming from the chart. The D distance is the distance from this guy's centroid, which would be 5 inches up, minus this. So the difference there gives me 199. 199 squared times the area is going to yield 34.889. We will add these two together, and we'll notice we're coming up with 137.889. So 3, this is shape 3. So for 3, again, moment of inertia, it's 103. Area is exactly the same. D distance is exactly the same. So therefore, AD squared is the same. And then ultimately, our calculation here is the same. And again, because we've got symmetry, same part, that's what's happening there. So we get 399.81 inches to the 4th. And this would be your what we call the IXX. So if we're loading it in this direction or this direction, this is the amount of stiffness it is bringing to the table. So we're going to look in the other direction now and see how that changes things. So we're going to look at the Y direction. So we're going to have shape IY, area D, AD squared IY. And the D is, we're going to be looking from axis to axis and axis to axis. Okay, so shape 1, this time this is the base on this guy. So this is going to be 1 times 10 cubed divided by 12. So this is going to bring a lot more stiffness into that. That turns out to be 83.33. And notice the difference here is quite a bit different. Area is the same. Now D, because these composite y-axis is sitting right on top of the axis of this plate, D becomes 0. So in other words, it's not adding any more into it. So that's as stiff as it's going to get from that plate, because 0 plus that, you're getting 83.33. Okay, so for 2, we have the IY 3.93. They're not giving us much in that direction. The value here is the same. Now the D distance for 2 would be this distance minus this 0.649, because what's happening, we're going from the back over to its centroid, so we're looking from axis to axis. So if we subtract that from 5, we should come up with 4.351. Square that times that gives us 166.784. So because of that distance of separation, it's actually generating a lot more stiffness. So when we add these two together, we come up with 170.714. So the last one here, I'm going to have again 393, 8.81. Now this distance is the same thing as that distance because it's symmetric. 4.351. So that squared gives me this. And ultimately you get that. So when we sum this, we'll notice that we get 4.248, and that would be inches to the 4th. So what you have, IXX is 399.81 inches to the 4th. The IYY direction, 424.8 inches to the 4th. So what this tells us, if we loaded it this direction or this direction, it's a little bit stiffer than it would be this way. So essentially they're pretty much about the same, but you do get a little bit of a difference. So that would be the process on that.